Welcome to today's Explainer. We're looking at a massive, and I mean absolutely massive, paradigm shift in artificial intelligence. For the longest time, we've kind of just thought of AI as this remarkably fast digital assistant, right? You ask it a question, it fetches the answer. You ask it to summarize a massive document, and, well, it complies. But we are officially crossing a threshold. We're moving away from AI that simply retrieves or reorganizes information to AI that is actively inventing brand new science. Today, we're unpacking a truly fascinating white paper from Google DeepMind that introduces AlphaEvolve. It's a system that fundamentally redefines what machine intelligence is actually capable of.
Okay, let's dive into this. For exactly 56 years, a specific mathematical benchmark stood completely unbroken. We're talking about the brightest human minds, the absolute most advanced supercomputers, generations of brilliant mathematicians, and literally none of them could find a more efficient way to perform a foundational computer science calculation known as Strasson's algorithm for certain matrices. It was this 56-year-old brick wall. But recently, an AI didn't just understand that wall was there, it built a door straight through it.
So that brings us to the central high-energy question of our explainer today. Can AI actually invent something entirely new? Not just remixing human knowledge, but actually discovering profound mathematical truths and highly complex algorithms that no human being has ever even conceptualized before? Well, the answer, as we're about to see, is a resounding yes. Here is our roadmap for unpacking this black box of invention. 1. The AI that invents. 2. The problem with discovery. 3. Inside the evolutionary loop. 4. Breaking a 56-year record. And finally, 5. Optimizing the real world. Starting off with Section 1, the AI that invents, and how we are moving beyond fun search. To really get this, we first need to understand that AlphaEvolve is what's called an evolutionary coding agent. Basically, it's an AI designed to autonomously improve algorithms by actively modifying their underlying code. Now, what's really interesting about this slide is the sheer scale jump from its predecessor. You might have actually heard of DeepMind's earlier project, FunSearch. FunSearch was great for sure, but it was kind of limited to single, small Python functions. AlphaEvolve just completely shatters those limitations. It evolves entire code files spanning hundreds of lines in any programming language. Using state-of-the-art LLMs, it leverages rich context and feedback, optimizing for multiple metrics all at the same time. To put it in perspective, it's basically the difference between a student solving a single math equation and a lead engineer architecting a massive software platform. Moving right along to Section 2, the problem with discovery and why current LLMs struggle so much with it. Why do standard models have such a hard time inventing? Well, it's because true discovery is a grueling trial-and-error process with a lot of backtracking, whereas standard LLMs are really just built to predict the next word. And this is exactly where the AlphaEvolve architecture completely changes the game by splitting the workload. The human scientist defines the what, setting the rules and the ultimate goal or the automated evaluation criteria. Once that's set, the AI steps in and takes over the heavy lifting of figuring out the how. By strictly relying on the human's automated grading system, the AI doesn't get derailed by incorrect hallucinations. It rigorously tests, keeps what works, and immediately discards the rest. All right, Section 3. Inside the evolutionary loop, or the tireless engineer. Let's slow down for a second here. I want you to picture a giant room full of digital engineers who literally never sleep. They are just constantly proposing tweaks, instantly testing code, tossing out failures, and building upon tiny incremental successes. And this brilliantly illustrates the engine driving that whole process, the distributed controller loop. The different components talk to each other seamlessly. You have the prompt sampler pulling up historical data, the LLM ensemble generating new code, the evaluators rigorously testing it, and then the program database storing the winners. It is just this continuous, completely autonomous circle of improvement. Let's break that evolutionary loop down step by step so we can fully grasp the mechanics here. Step 1 is the prompt. The system samples past successful ideas right from its database. Step 2 is generate. The AI proposes a totally new modification based on those past wins. Step 3 is evaluate. The system runs the code to see if it actually performs better than the older version. And finally, Step 4 is register. If it's a win, it registers and saves that new code back into the database as the new champion to beat. Generation after generation, the algorithm just gets sharper, faster, and way smarter. Now, to power this crazy loop, the system actually relies on a carefully balanced ensemble of LLMs. It uses Gemini 2.0 Flash for sheer speed, just churning through thousands of rapid-fire ideas and mutations. But it pairs that with Gemini 2.0 Pro, which steps in kind of like a senior engineer to provide occasional, highly complex breakthrough suggestions. It really is the absolute perfect balance of relentless speed and deep, thoughtful reasoning.
Let's move to and see how this builds down at the coding level, because it works with surgical precision. When the AI wants to change the algorithm, it doesn't just rewrite the whole file from scratch. That would be total chaos. Instead, it outputs highly specific formatting called diff blocks. It finds an exact segment of the current program, marked by a search block, and literally swaps it with a replace block. This lets the AI make really targeted, precise updates to massive codebases without breaking all the surrounding architecture.
Section 4. Breaking a 56-year record, tackling Strassen's algorithm. Okay, let's get back to that hook from the very beginning of our explainer. What exactly did AlphaEvolve achieve that completely shocked the mathematical community?
Well, here is the mind-blowing achievement directly from the DeepMind paper. AlphaEvolve tackled the fundamental problem of matrix multiplication, which is a core operation in pretty much all modern computing. Specifically, for 4x4 complex-valued matrices, a method known as Strassen's algorithm had held the absolute record for efficiency since 1969. But AlphaEvolve discovered a totally novel procedure to do this using only 48 scalar multiplications. It offered the first algorithmic improvement in this setting in over half a century. Think about that. An AI literally evolved a piece of math that humans couldn't figure out for decades.
So the crucial point is, this wasn't just some lucky fluke. The researchers unleashed AlphaEvolve on over 50 open mathematical problems. On about 75% of those problems, it matched the absolute best-known human constructions, which honestly, in many cases, are likely already at the mathematical limit. But on roughly 20%, it actually surpassed the state-of-the-art. It discovered new, provably better constructions across all sorts of complex mathematical spaces. It is a wildly consistent, high-performing discovery engine.
Which brings us to Section 5, optimizing the real world, moving beyond abstract math. We've talked a lot about abstract math and theoretical computer science today, but how does an AI that invents algorithms actually impact your everyday digital life? Well, it matters because those exact abstract algorithms power the digital infrastructure of our entire world. AlphaEvolve was applied to critical layers of Google's massive compute stack. It actively developed more efficient scheduling heuristics for real-world data centers. It optimized the arithmetic circuits inside hardware accelerators. And in a totally mind-bending twist of meta-engineering, AlphaEvolve was used to optimize the matrix multiplication kernels used to train large language models. Yeah, that means the AI actually improved the foundational training process of the very AI models that underpin it.
So all of this brings us to a rather profound closing thought. If a system like AlphaEvolve can just be handed a set of evaluation criteria and then autonomously invent novel algorithms, break 56-year-old math records, and optimize global data centers, as AI transitions from merely answering our questions to actively inventing the future, what exactly is the future role of the human scientist? Are we simply becoming the directors of automated discovery? It's an incredibly fascinating paradigm shift, and it's definitely one that will redefine the boundaries of human and machine collaboration for sure. Thanks so much for joining me on this explainer, and keep exploring.